In this video, we're going to look at another curve sketching example. So again, we're going to jump right into it. Here we have f of x equals x to the fourth minus 12x cubed plus 48x squared minus 64x. So our first step, we're going to think about what are the x-intercepts. So we set our function equal to 0. And we can factor out an x. So we factor out that x. The remaining stuff, it factors to x minus 4 cubed. And so x equals 0 and x equals 4. Those are our x-intercepts. The y-intercepts, or y-intercept, we plug in an x value of 0, and we get a y value of 0 as an output. Next, we want to think about our domain. This is a polynomial. So the domain is all real numbers. Since our domain is all real numbers, there are no points of discontinuity. Good. Next, we want to look at our intervals of increase and decreasing. So we're going to take a look at our first derivative. Our derivative, we get 4x cubed minus 36x squared plus 96x minus 64. We can factor that into 4 times x minus 1 times x minus 4 squared, setting it equal to 0. Would tell us that x is equal to 1 or 4. So those are the points that we're going to split up our intervals at. So for our sign chart, f prime of x, we're going to go from negative infinity up to 1, from 1 to 4, and then from 4 to infinity. And if we were to plug in a value smaller than 1, so like 0, plug that into our derivative, we'd have a negative times a positive, which is negative. Plug in something between 1 and 4, we will have a positive times a positive, which is positive, and past 4 we'll have positive times positive, which is still positive. So what does that tell us about our function? F is increasing on the interval from 1 to 4, along with 4 to infinity. And it is decreasing on the interval from negative infinity to 1. We have a minimum at 1. So when our x value is 1, if we were to plug that into our original function, our y value is negative 27. And what's happening at 4? Well, that is a saddle point. We have a saddle point. at 4, comma, 0. And so it kind of slows down right at that point. It neither increases nor decreases, and then it's going to keep going. All right, now we're going to look for intervals of concavity. So when is it concave up and concave down? Our first derivative was 4x cubed minus 36x squared plus 96x minus 64. So our second derivative is 12x squared minus 72x plus 96. Set that equal to 0. We can factor out of 12, and then it will factor into 12 times x minus 2 times x minus 4. Set each of those pieces equal to 0, and so x is equal to 2 or 4. So when we do our sign chart here for the second derivative, we're going to go from negative infinity up to 2, from 2 to 4, and from 4 to infinity. Plug in something smaller than 2, so like a 0, and we get a sign for the second derivative that is positive. Plug in something between 2 and 4, like 3. We'll get a sign that is negative, and past 4, we get a sign that is positive. So f is concave up on negative to infinity to 2, along with 4 to infinity. F is concave down on the interval from 2 to 4. We have inflection points at, so when our x value is 2, the y value is negative 16. And when our x value is 4, the y value is 0. So we have inflection points right here when the x value is 2, and plugging that into the original function gives us 2 negative 16. Changes from concave down to concave up. Or it could be concave down to concave up. And then we have going from concave down to concave up here. Oh, so this is concave up to concave down. Yep. So we have inflection points at those two values. Let's look at the end behavior. Limit as x approaches infinity. As x heads towards infinity, this function is heading towards infinity. As x heads towards negative infinity, this function still heads towards infinity. Right, so on both of those, really what I would imagine doing is factoring out an x to the fourth. And so this piece heads towards infinity in either case. All this mess heads towards 0, so you just have infinity times 1. And so they're both heading towards positive infinity. All right, so now let's put it all together and graph this thing. So our graph we had at 0, 0. We had a point there. 1, 2, 3, 4. We had an inflection point, a saddle point, inflection point at 4, 0. An inflection point down here at somewhere further down at like negative 27. And our graph looks like something like that. It's concave up. All the way to here. It's decreasing up to this point. Then it's increasing from that point on. It is concave down here, and then concave up. And that is our example. Come on back for one final example that involves trig functions. We will see you there.